So here I'm going to go through a Leaving Cert past paper question on trigonometry. It's a unit circle question from 2020, paper 2, question 4, and it says find two values of theta for which tan of theta over 2 is equal to minus 1 over root 3. First thing for these questions is that we're going to want to find the reference angle. And to do that, we're going to be using our tables. I'll just show you that now. So we know that tan of theta over 2 is equal to minus 1 over root 3. So we're going to look to tan and we're going to see what angle gives us 1 over root 3. And you can see it's 30 degrees here. It's asking for in radians. So we're just going to do this question in radians. If you want, you can do it in degrees and then convert at the end. Make sure you do convert at the end. But I know that the reference angle here, when I go from tan, I know it's 1 over root 3. Then the reference angle there is this one here, pi over 6. So it's pi over 6. Then I need to look at the quadrants where tan is negative. And if you remember from before, if you split the 4 quadrants, C, A, S, T, cast, and we're looking for where is tan negative. If you want to find more on this, actually go back to the unit circle video where I introduced it. But all trigonometric ratios are positive in the first quadrant. Sine is the only one that's positive in the second. So tan is negative there. Tan is positive in the third. And cosine is the only one that's positive in the fourth. So we're looking at the second quadrant and the fourth quadrant where tan is negative. Now the second quadrant here. So we've got a reference angle of pi over 6. What that means is that angle there is pi over 6. Reference angle means the angle that is taken from the x-axis, and the actual angle we want is that from the positive sense of the x-axis. So if that's pi over 6 and that whole distance here is pi, then the actual angle in the second quadrant becomes pi minus the reference, pi over 6. So that's 6 pi over 6 minus pi over 6, so it gives us 5 pi over 6. Again, if you wanted to do this in degrees and convert, you could. So that will be 30 degrees. This whole thing in orange there will be 180 degrees. So the actual angle in the second quadrant becomes 150 degrees, which in radians is 5 pi over 6. So then we go through our strategy. It says theta over 2 is equal to that. So theta over 2 is equal to 5 pi over 6 plus, in our general form, 2n pi. Now we're actually interested in what theta is, so we multiply everything by 2. So theta is equal to 5 pi over 3 plus 4n pi. And now all we're going to do is substitute values of n. So when n equals 0, we've got 5 pi over 3 plus 0 pi, which is 0. And when n is equal to 1, we've already gone back around the entire circle there, so there's no more values of theta there. So this is going to be one of our answers, 5 pi over 3. Next, we look at the fourth quadrant, and for our fourth quadrant here, if that's pi over 6, the actual angle will be all the way from the positive sense of the x-axis. So it's going to be 2 pi minus pi over 6, which is 11 pi over 6. So the answer then will be theta over 2, just like we did in the second quadrant. We follow the same thing. Theta over 2 is equal to 11 pi over 6 plus 2n pi. Now when we multiply everything by 2 there, we've got theta equals 11 pi over 3 plus 4n pi. Again, we start introducing values of n beginning with 0, which don't duplicate themselves. So what we're going to find here is, so let n equal to 0, theta is equal to 11 pi over 3. And they are the two values of theta. So now we'll look at the next question. It's more of a problem solving question here. So here we're told we've got a sector of a circle with radius 7 with a center O. In the sector, BOA is 1.2 radians, so they give it to us in radians here instead of degrees. The area of the shaded region is 21 centimeters cubed, and we're asked to find BC. Well, I know that OB, BO, is 7. So basically, if I can find that distance there, I'd be able to find BC. Well, let's try and find some information about CO there. I'm told that the area of the shaded region is 21 centimeters cubed. If I can work out the area of that triangle, then I should be able to find out what CO is. So we're going to go to our tables again, and we can see here that the area of a sector is 1/2 r squared theta, where theta is the angle here. So we're going to use that now. So the area of the triangle COA, or CAO, is going to be sector minus 21. Well, the sector is going to be 1/2 of 7 squared times 1.2. And we've just taken that from the tables, and that's going to be minus 21. So our total area is half of 49 times 1.2, which is 29.4, minus 21, which is 8.4. Okay, so I know that this whole area there is 8.4 centimeters squared. And the area of a triangle, if we look here, the area of a triangle is 1/2 of AB times sine of C. So the area of the triangle, half of both sides, so C times O times 7 times sine of the angle in between, which is 1.2 in radians. So therefore 8.4 is equal to 1/2 of CO times 7 times sine of 1.2. When I rearrange that equation, CO is equal to 16.8 divided by 7 times sine of 1.2. The important thing, make sure your calculator is in radians here. So it's going to be 16.8 divided by which is 2.5749 or 2.6 in one decimal place. That's what CO is, so therefore BC is equal to 7 minus 2.6 to one decimal place, so you got an answer there, 4.4 centimeters.